Good afternoon, students. We will start our lecture. Okay, so in yesterday's lecture, we have covered the deadlock point. Okay, first we have covered the graph-based protocol. So in the tree format, uh, we display the graph-based protocol. Okay, then we have seen the deadlock handling concept. Okay, so we have seen what is deadlock if number of transactions are there and if every transaction is waiting for another transaction to release the lock on the data item. Okay, if this chain continues, okay, if the 10 transactions are there and all the 10 transactions are waiting for each other to release the lock on the data item, then we can say that there is a deadlock in the system. Okay, then we have seen how to handle the deadlock problem. So basically there are two methods to handle the deadlock problem. The first one is deadlock prevention, and the next one is the deadlock detection and deadlock recovery. Okay, so the prevention means we have to ensure that the deadlock never occur in the system. Okay, means we have to prevent from the occurrence of the deadlock. And detection and recovery means what? If in case the deadlock is occurred in the system, then we have to handle that deadlock. So how to handle the deadlock? So by just recovering, or we can say by just uh, uh, by performing the rollback operation, we can recover the deadlock. Okay, then again in the deadlock prevention, we have seen some mechanisms to prevent the deadlock. So in that, the first mechanism, it was pre-declaration. Okay, means lock all the data items before starting of the execution. Then the graph-based protocol. So here we have to maintain the some partial ordering of the data items, and in that ordering only we have to lock the data items. Okay, then we have seen the preemption and the rollback technique. Okay, means uh, if one transaction is waiting for the another transaction, then we can take lock from that transaction, uh, uh, and we can give that lock to the another transaction, okay, or to the transaction who is currently waiting. Then in the deadlock prevention scheme, we have again uh, we have seen the two different schemes. The first one is the non-preemptive scheme, and the next one is the preemptive scheme. So both these schemes, they are using the timestamp, okay, to prevent the deadlock. So the first non-preemptive scheme is nothing but the wait die scheme. Okay, and the preemptive scheme is nothing but the bound wait scheme. So in both the schemes we are using the timestamp, and depending on the value of the timestamp, we can decide which timestamp is greater and which timestamp is smaller. Okay, and in both the scheme, if means depending on the time of the timestamp, if the timestamp is smaller, then the transaction may wait or the transaction may die or roll back. Okay, so in both the schemes, the major part is the timestamp value. Okay, then we have seen another deadlock prevention technique as the timeout based scheme. Okay, so in the timeout based scheme, the transaction waits for some time, some specified time, okay, for the lock, and after that time elapsed, the transaction is rolled back. Okay, so the simple scheme is timeout based scheme. Okay, then we have seen the deadlock detection uh, techniques. Okay, so deadlock detection means how to detect the deadlock. Okay, so if in the system the deadlock is present, then it is described in the form of directed graph. Okay, and that directed graph is called as the wait for graph. Okay, so if in the graph there is a age from one transaction to the another transaction. So meaning of that age is nothing but the first transaction is waiting for the another transaction to release the lock on the data item. Okay, so uh, if if we want to show the deadlock, then we can use the wait for graph. Okay, and again in the wait for graph, if the wait for graph contains any cycle, then we can say that yes, there is a deadlock occurred in the system, or the system is in the deadlock state. Okay, so the important point is, if the wait for graph contains the cycle, then that system is in the deadlock state. Okay, so we have seen one diagram that the wait for graph without cycle and wait for graph with cycle. Okay, if the cycle is present means what? All the transactions present in that cycle. So every transaction is waiting for the another transaction to release the lock. Then we have seen the deadlock recovery concept. Okay, so to recover the system from the deadlock, we have to follow three steps. The first step is that the selection of the victim. Selection of the victim is nothing but we have to select the transaction to roll back. Okay, then the second one is rollback, means here we are actually performing the transaction rollback. Okay, again we can perform the total rollback, or we can perform the partial rollback. Total rollback means we can abort the transaction and again we restart that transaction, and the partial rollback means we can abort the transaction only up to some part of that transaction, okay, which is necessary. And the third step is the starvation. Okay, so the starvation means if the same transaction is always selected as the victim, then it is possible that the starvation may occur. Means what? The transaction never completes its assigned task. Okay, so these three are the steps for the deadlock recovery. The first one is selection of the victim, then rollback and starvation. Then we have seen the next point of the chapter as the multiple granularity. Okay, so the multiple granularity is nothing but if we know that every transaction that want to use any kind of data item, so that transaction must have to log that data item. Suppose one transaction uh, want to access whole database or the entire database, and obviously that database contains number of files, or we can say that database contains number of data items. Okay, so if that transaction is locking each and every data item individually, then it is very time consuming, because the transaction require the entire database. So it is easy to use the single lock to uh, use the single lock request to log the entire database. Okay, but in some cases it is also possible that the transaction require only few data items from the database. Okay, so in this case the individual lock request for every data item is good, we can say it is good. But if in the second case also, if that transaction is acquiring the lock on whole database or on the entire database, then it may possible that any another transaction that require the another data items in that database, then that data items are not available for that another transaction. Okay, so unnecessarily the second transaction logs the whole database. Okay, means because of this the concurrency of the data is lost. Okay, so the solution for this is, means some transaction require the lock on whole database and some transaction require lock on few data items. So the solution is we can use the multiple granularity concept. Okay, means we can define different levels of the granularity. So here it allows all the data items of different sizes. Okay, and it defines the hierarchy of the data granularity. And in the hierarchy of the data granularity, the small granularities are nested in the larger granularity. Again, the multiple granularity is also represented by the tree. Okay, so this is the example for the multiple granularity hierarchy. So in this, the very first level, or we can say the topmost level, is nothing but the database. Okay, so below the database, different nodes of areas are there. Okay, and every area contains the file of type area. Okay, and every file contains individual record type. Okay, so this is the level of the granularity hierarchy. Okay, then in the with the multiple granularity, we can lock the data item explicitly. Okay, generally we are locking the data item explicitly. Okay, and it uh, automatically implicitly locks all the node descendants in the same mode. Means if one transaction is explicitly locking the parent of any subtree or the parent of the tree, then it implicitly or it automatically implicitly locks all the child nodes of that tree. Okay, so this one will work automatically. Okay, then we have seen some additional lock modes with the multiple granularity. That modes are called as the intention lock mode. Okay, so there are three additional lock modes: intention shared mode, intention exclusive mode, and the shared intention exclusive mode. Then we have seen the compatibility matrix for all the lock modes, and we have also seen if any transaction want to lock any data item in any node, then how to lock that data item. Okay, so we have seen some rules for locking the data item. Okay, so up to this we have seen in the last lecture. Now today we will see our next point as the timestamp based protocol. Okay, so the timestamp based protocol. So in the timestamp based protocol, every transaction is uh, assigned a unique timestamp. Okay, so timestamp is nothing but the just a value when that particular transaction enters into the system. Okay, so the timestamp is nothing but it is the value when a particular transaction enters into the system. Okay, so every transaction is having the unique timestamp. Okay, and it is denoted by ts of ti. So this ts of ti is nothing but the timestamp value, uh, and in bracket ti is nothing but the name of that transaction. Okay, and we know that the multiple transactions may execute in the system. So if transaction ti is already entered into the system, and if the new transaction enters into the system, consider the tj. So that new transaction is having the greater value for the timestamp than the older one. Okay, so whenever new transaction enters into the system, so that transaction must have the greater value for the timestamp than the older one. Okay, for example, if the transaction ti, okay, has been assigned a timestamp ts of ti, okay, and a new transaction, consider the transaction tj, enters the system, then ts of ti less than ts of tj. Means what? Here the newer timestamp is the tj, sorry, the newer transaction is the tj, and the older transaction is the ti. Okay, so the timestamp value of the newer transaction, that is tj, is greater than the older transaction ti. Okay, then there are two methods for uh, allocating the timestamp or for implementing the timestamp scheme. So these two methods are, the first one is the system clock and the next one is the logical counter. Okay, system clock means what? We can the system clock means uh, the time or the value for our uh, the value of our system clock or the value of our uh, time of the machine. Okay. Here in the system clock, we can use the value of the system clock as the timestamp. Okay, means the transaction's timestamp is equal to the value of the clock when the transaction enters the system. Suppose a new transaction enters into the system, and at that time in my system or in my machine clock, suppose 3 o'clock, this value is there. So we can assign that 3 value to the transaction's timestamp as a transaction timestamp. Okay, so we can use the system clock value as a timestamp to allocate the timestamp value to the transaction. So this is the one method. Now another method is that by using the logical counter. Okay, so this logical counter is incremented after the new timestamp has been assigned. Okay, means if the new transaction comes into the system, okay, then we can also say that this logical counter will be incremented after every new timestamp has been assigned. Means here the transaction's timestamp is equal to the value of the counter when the transaction enters the system. Okay, so here in the second method, according to the logical counter, we can give or we can assign the timestamp value to the transaction. Okay, so we have seen the two methods. The first one is the system clock, means according to the value of the system clock we can assign the timestamp value, and the another one is the logical counter. So according to the value of that counter we can assign the timestamp value for the transaction. Okay, so these timestamp based protocols, they manage the concurrent execution. Okay, means what? Timestamp order is equal to serializability order. Means if we use the timestamp to every transaction, then we can execute the serial schedule. Okay, so it is always true that if we are using the timestamp value for every transaction, then we can execute the serial schedule. Okay, then to implement the timestamp concept, we have to use the two different timestamp values. Okay, means for every with every data item queue, there are two different timestamp values. The first one is the W timestamp and the next one is R timestamp. Okay, W timestamp, it is for the write value, means value which is written, and the R timestamp, it is for the read data item. Okay, so the W timestamp, it denotes the largest timestamp, okay, of any transaction that executed write queue successfully. So if any transaction executed the write operation for the data item, so this write stamp is the value for this write stamp timestamp is largest. Okay, so the W timestamp is nothing but it denotes the largest timestamp of any transaction that executed the write operation. Okay, so similarly for the read timestamp, so this read timestamp, it denotes the largest timestamp of any transaction that executed the read operation successfully. Okay, so the transaction can read the data item which is having the largest timestamp. Okay, and the transaction can write the data item which is also having the largest timestamp. Okay, means largest timestamp is nothing but that value is written or that value is read earlier. Okay, means we are reading or we are writing the latest value of that data item. So for this purpose, we are using the W timestamp and the R timestamp. Okay. So this timestamp they impose the rules on the read and write operation. Okay. They uh, they force some rules on the read and write operations to ensure that any conflicting operations are executed in the timestamp order. Okay, and out of order operations cause transaction rollback. Okay, so if we are using the timestamp in the transaction, means what, all the operations they are executing in that timestamp order only, and if some transaction or if some operations are out of order, then we have to roll back that transaction. Okay. Then uh, the next one is uh, timestamp based protocol. Okay, so we have seen the exactly what is meant by timestamp. Okay, and we have seen the read timestamp and the write timestamp. Okay, now we'll see the timestamp based protocol. Okay, so consider that the transaction Ti it issues the read operation. Okay, means the transaction Ti want to execute the read operation on the data item Q. Now for this, the two possibilities or the two conditions are there. So among that, the first condition is that, so if the timestamp of the transaction means TS of Ti is less than W timestamp. Okay, if the transaction's timestamp is less than the write timestamp, then the transaction Ti needs to read a value of the queue that was already overwritten. Okay, if the transaction's timestamp is less than the write timestamp. Okay, write timestamp means whenever any data value is written, so at that time that timestamp is updated or that timestamp is latest. But here the transaction's timestamp is less than the write timestamp or the W timestamp. Then in this case, the transaction Ti reads the value of Q which is already overwritten. Means we can say that the transaction Ti can reads the old value of the data item Q. Okay, means here the read operation is rejected and the Ti is rolled back. Okay, so if the transaction needs to read the old value of the Q, then what is the use of that transaction? So in this case, that read operation is rejected and we can roll back the transaction Ti. Okay, now for the read operation, again the second condition is that if the timestamp of the transaction is greater than equal to the W timestamp. Okay, now here the transaction's timestamp is greater than the write timestamp. Okay, then the read operation is executed and the R timestamp is set to, means if the transaction's timestamp is greater than or equal to the write timestamp. Okay, means here we can read or that transaction can read the latest value of the data item, and after this the value of the R timestamp is equal to the maximum of R timestamp comma transaction timestamp of the transaction. Okay, simply two cases for the read operation. The first case is that if the transaction's timestamp is less than the write timestamp, okay, then there is no use of the read operation. Means the transaction can read the old value. Okay, so in this case we can roll back that transaction. Okay, and uh, if the transactions timestamp is greater than the W timestamp, then the transaction can read the latest value written by that written for that data item Q. Okay, so two conditions for the read operation. Okay, so have you understood the two conditions for the read operation? Okay, now uh, again the few conditions for the write operation. Okay, suppose the transaction Ti issues the write operation or write of Q. Okay, then in this case also, if the timestamp of the transaction is less than the read or is less than the R timestamp of Q, okay, then the value of Q that Ti producing was needed previously, and the system assumed that the value would never be produced. Okay, if the transaction's timestamp is greater than, sorry, if the transaction's timestamp is less than the read timestamp of that data item. Okay, means what here, the read timestamp value is greater. So in this case, the the value of the data item Q that the transaction is producing, so that value was needed previously only, and the system thinks that the value would never be produced. Okay, so in this case, the write operation is rejected and the TI is rolled back. Okay, means we cannot write uh, we cannot write any value for the data item Q. So simply that write operation is rejected and that transaction is rolled back. Now second condition is that, so if the transaction timestamp of the transaction is less than the W timestamp, okay, then the TI is attempting to write an absolute value of the Q. Means if the transaction's timestamp value is less than W timestamp, then in this case Ti is writing the value of Q which is not in the use. It means that value is not in the use. Okay, so in this case also the write operation is rejected and again the transaction is rolled back. And otherwise, means if above two cases are not there, then the write operation is executed and the W timestamp is set to TS of Ti. Means the updated W timestamp is set to timestamp of the transaction. Okay, understood? So these are the conditions for the transactions to execute the write operation. So if again the timestamp of the transaction is less than both read and write timestamp of the data item, then in both the cases write operation is rejected. We cannot proceed the write operation, so that write operation is rejected and the transaction is rolled back. And if other than these two conditions, means what, if the transaction's timestamp is greater than equal to read or write timestamp, then in this case only we can write we can perform the write operation on the data item. Okay, have you understood the timestamp based protocol? Okay, now here the schedule. Okay, here is the schedule under the timestamp ordering. Okay, so this schedule is the serial schedule. Okay, we can say this schedule is the serial schedule because consider that the timestamp value of the T25 is considered 25 and the timestamp value of the T26 is 26. Means what? The transaction T25 should execute first. Means the transaction T25 should start to execute first and after that transaction TT will execute. Okay, so if the T25 will execute first and after that T26 will execute, then after execution of these two transactions or after execution of this schedule, we can say that the value of A and B are consistent, and we can say that this schedule is the serialized schedule. Okay, so with the help of timestamp ordering protocol, we can generate the serialized schedule, or the order of the transaction to execute is the serialized order. Okay, so this one is the example. So the schedule is same as we have seen in our previous schedules. Okay, so this schedule is the same, just the difference is that for these two schedules we have allocated the timestamp value, and among these two the timestamp value of the first transaction, that is T25, is less than the timestamp value of the second transaction. So in this case we will execute first this T25 transaction, and then we'll execute the T26 transaction. Okay, so then there are some correctness of the timestamp ordering protocol. So this the timestamp ordering protocol, it guarantees the serializability. Okay, means with the help of timestamp ordering protocol, we can execute the serial schedule. So it will guarantees the serializability of the transaction. Since all the arcs in the precedence graph are of the form, means what? Uh, this timestamp ordering protocol will assure the serializability of the transaction, because here the transaction with the smaller timestamp comes first, and then the transaction with the larger timestamp will present. Okay, so because of this only we can execute the schedule, we can execute the transaction in the serialized order. Okay, then the timestamp protocol, it ensures the freedom from the deadlock. Okay, because means with the help of timestamp ordering protocol, the deadlock never occur in the system, because here no transaction is waiting for the another transaction. Okay, means no waiting transactions are present here, so that uh, the deadlock will never occur in the system. Okay, but the schedule may not be cascade free. Means what? Here the cascadeless schedule may be present with the timestamp ordering protocol and may not even be recoverable. Okay, so that schedule that we have seen, that schedule is serialized schedule, that schedule is deadlock free schedule, but that schedule is not cascade free. Okay, that schedule, it may be cascadeless schedule, or that schedule is not recoverable also. Okay, so to recover the cascadeless schedule, uh, we have to use, there are some solutions. Okay, and we have to use that solutions, so that recoverability and the cascadelessness of the uh, timestamp ordering protocol, so it can be ensured, it can be guaranteed by using the three solutions. Okay, so very first solution is that the transaction is structured such that its writes are all performed at the end of its processing. Okay, so if all the write operations are performed at the end of the processing, then we can guarantee for the recoverability and the cascadeless schedule. Okay, so all writes of the transaction form an atomic action, so no transaction may execute while a transaction is being written. Okay, so if we return all the write operations at the end of its processing, uh, then in this case, while writing the transaction, or whenever any transaction is being written, so no other transaction may execute at that time. Okay, then the transaction that aborts is restarted with the new timestamp. Suppose in case any transaction is aborted, then that transaction is restarted with the new timestamp value. Okay, so using this way also we can ensure the recoverability and the cascadelessness schedule. Okay, so one way or one solution is, the first solution is that uh, allow all the write operations to perform at the end of the processing. Okay, so because of this, whenever the transaction is being written, then no other transaction is going to execute. Then the solution 2 is that the limited form of locking. Okay, means uh, another form is that the limited form of locking, means here wait for the data to be committed before reading it. Means here the transaction can wait for the uh, wait for wait to commit the transaction, okay, before reading that transaction. Means what, if once the transaction will committed, then obviously uh, that data item is having the final value of the transaction. Okay, so once the transaction is committed, then only we can read that transaction. Okay, so this is the another solution. And the third solution is that use the commit dependencies to ensure the recoverability. Okay, again, if we are executing the transaction, and if the transactions are committed, okay, means if there is a commit dependencies, then also we can ensure the recoverability of the schedule. Okay, so these three are the solutions for the recoverability and the cascadelessness of the schedule uh, in the timestamp ordering protocol. Okay, now the last point is validation based protocol. Okay, so this validation based protocol, it is also another kind of concurrency control protocol. Means again, to execute the transactions in a serial order, generally we are using all these protocols. Okay, to execute or to commit the transaction in the serialization order, we are we know that in the timestamp ordering protocol, we postpone the write to the end of the transaction. Means we perform all the write operations at the end of the processing or at the end of the transaction, and keep track of all the data items read or written by the transaction. Means whatever the data item written or read by the transaction, we have to keep track of all that data items. Okay, so this validation perform at the commit time detect any out of serialization order read or write. Okay, so this validation protocol, it detect any kind of out of serialization order read or write operation. Okay, so this validation based protocol, so a validation based protocol is nothing but uh, we can means in the validation based protocol, basically we are executing the write operation at the end of the transaction. Okay, once once our transaction is valid, means once the system says that yes, our transaction is valid, then only we can execute the write operation of that transaction. Okay, so because of this only, we ensure the serializability of the transaction. So this validation protocol, it requires that each transaction TI executes in 2 or 3 phases. Okay, means in the validation protocol, for every transaction, total 3 phases are there. Okay, so this the transaction executes these phases depending on whether it is read only or an update transaction. Means whether that transaction is reading any data or whether that transaction is updating any transaction. Okay, so in the validation based protocol, the transaction can execute in 2 or 3 different phases. Okay, so these phases are, the first one is the read phase, then write phase, and the validation phase. Okay, total 3 phases are there: read, write, and validation. Now we will see first the read phase. Okay, so this read phase means in the read phase, the system execute the transaction Ti, okay, and it reads the value of the various data items and store them in the variables local to the Ti. So in the read phase, the transaction reads the value of various data items and it stores the value of that various data items in the variable which is local to the transaction Ti. Okay, and it performs all the write operations on the temporarily local variables without updates of the actual database. Okay, means they are only reading the data items. Okay, but they are not updating the actual database. They are just reading the data items. That is nothing but the read phase. Then validation phase. So the validation test is applied to the transaction. So this test determines that whether the transaction is allowed to proceed to the write phase without causing a violation of the serializability. If the transaction fails the validation test, the system aborts the transaction. Means after the read operation, when the transaction reads all the data item values, okay, so that transaction will perform the validation phase. Okay, so in the validation phase, the transaction first have to perform the validation test. Means that validation test is applied on the transaction. Okay, then if that test is successful, then the transaction is allowed to proceed for the write operation. Okay, otherwise the system will abort the transaction. Okay, and the last phase is the write phase. So here, if the transaction Ti is validated, means if the transaction Ti successfully completed the validation test, then it updates the updates are applied to the database. Otherwise, Ti is rollback. Means what? That transaction can perform the write operation. Okay, and all that updates are applied to the database. Otherwise, again, if the transaction Ti is not validated, then that transaction is rolled back. Okay, so this is the write phase. So these three are the phases in the validation protocol. Okay, so every transaction comes which is present in the validation protocol. So for that transaction, you have to execute all the three phases. Read phase means the transaction can read all the data items value. Okay, validation phase means so if the validation test means the validation test is applied to the transaction, and if that transaction is allowed to proceed for the write operation only after if the transaction successfully completed the validation phase. Okay, and the last one is the write phase. Okay, so here if the transaction is validated, then only it allowed to update the database. Otherwise, the transaction will roll back. Okay, so these three phases of the phases of concurrently executing transactions can be interleaved, but each transaction must go through the three phases in that order. Means this order is important. First, every transaction have to read the data items. Then the validation of the transaction is performed, and then the transaction is allowed to write the data item, perform the write operation. Okay, so we assume that the validation and the write phase occur together. Okay, means both the validation and write phase both are, we can say that both are same, and they will execute serially or they will execute togetherly. Okay, so uh, uh, so every transaction in the validation based protocol, so every transaction has the three timestamp. Okay, we have seen exactly the what is the timestamp, but the transaction in the validation based protocol is having the three timestamps. First is the start timestamp, then validation timestamp, and the last one is the finish timestamp. Okay, so the start timestamp means the time when transaction started its execution. Okay, so it is very common. So the start timestamp is nothing but when the transaction start its execution. So at that time, this timestamp is allocated. Then validation of TI is nothing but the time when transaction finished its read phase and started its validation phase. Means once the uh, uh, once the read operation of all the data item is completed by the transaction, so after that the validation phase of the transaction started. Okay, and the finish timestamp is nothing but the time transaction when transaction finished its write phase. Okay, so this is the last timestamp we can say when transaction uh, completes its execution, or when transaction finished its write operation, write phase, then this timestamp is executed. Okay, so this validation test use above timestamp and the read or write sets to ensure that the serializability order is determined by the validation time. Means we can say that the timestamp, okay, normal timestamp of the transaction is equal to the validation timestamp of the transaction. So both are same. Okay. So in the timestamp order protocol, we have used the timestamp of the transaction, and here in the validation based protocol we have seen the validation of the transaction, validation timestamp. So both are same. So in the timestamp ordering protocol also, when the transaction enters into the system, it starts its execution. Okay, and after validation timestamp also, the transaction can perform the write operation. So both timestamp are we can say are equal. Okay, so the next point, it is for the validation test for the transaction. Okay, so in the description of the validation based protocol, we have seen that in the second phase, that is in the validation phase, every transaction have to perform the validation test. Okay, so if that validation test is successful, then and then only write transaction can execute the write operation. Okay, so what is that validation test? So this validation test is for the transaction requires that for all the transactions TK, means we can perform validation test for the for any single transaction. So for that single transaction, consider here TI. So for that transaction, all transactions TK, means we can say that the another transaction, all the transaction TK with timestamp of the TK is less than timestamp of the TI. Okay, means what? This transaction TK comes first than the transaction TI, and here we are performing the validation test on the transaction TI, means we are performing the validation test on the newer transaction. Okay, so for this validation test, the two conditions must hold. Okay, so the first is that first condition is that finish of TK less than start of TI. So this finish of TK means what? When the transaction completes its write operation. Okay, so this if the finish of TK is less than the start of TI, then in this case the TK means the first transaction completes its execution before the second transaction TI started. Okay, so here the serializability order is maintained. Obviously, if the first transaction completes its execution and then the next transaction is started, then the serializability order is maintained. So this is one kind of validation test. Okay, then second condition for the validation test is that start TS means start timestamp of the transaction TI less than finish timestamp of the transaction TK less than validation timestamp of the transaction TI. Okay, so this condition ensures that the write of the TK and the TI, okay, means in both cases here we are writing finish of TS of TK means what, we are writing the value of transaction TK, and validation TS of TI is nothing but both the writes of the TK and TI do not overlap because the values are means the conditions are lesser. Okay, so here the write of the TK do not affect the read of the TI because here in the with the help of this the finish of TSTK we are writing the data we are writing the data item of transaction TK. So this it will not affect the read operation of the TI. So since the TI cannot affect the read operation of the TK, so here also the serializability order is maintained. Means if the order is like this, means the start of the transaction of the TI means that new transaction then is less than the finish of the old transaction. Okay, means obviously that old transaction is going to finish. Again, this one is less than the validation of the TI. So if this condition is also there, then also the serializability order of the transaction is maintained because both the read and write operation of the TK and TI they are not overlapping. Okay, so if the operations are not overlapping means what, they are executed serially. Okay, understood. So these two conditions are for the validation test. The first one is finish less than start means for both the transactions, and the next one is start finish and the validation. Okay, so if these conditions are executed successfully, then we can maintain the serializability order for the transaction. Okay, so the last one, the schedule produced by the validation means this is the example of the schedule. Again, we'll use the same schedule, that is T25 and T26 as we have used uh, in our timestamp ordering protocol. Okay, so here also the T25 will execute first, will start first. Okay, read the data item. Again in the T26 we are also reading the uh, data item of B and A. Okay, then in the T25 also again we are reading the data item of A. After read operation this validate will execute means that validation phase will execute. Okay, and after the validation phase only we are performing the write operation. Okay, so this is the correct sequence of the validation based protocols. First, read of all the data item will execute, then the validation test will execute on the transaction. Okay, and if the validation test successfully executed, then only the write operation will execute. Okay, so the execution of this schedule is also the serializable schedule. Okay, understood. The important point in the validation based protocol is that after execution of the read operation we have to perform the validation test, and and after that validation test only we can proceed for the write operation. And one more important thing is that all the write operations are what we can say, all the write operations are executed at the end of the transaction. Okay, so this is also one of the condition for the validation based protocol. Okay, so have you understood timestamp ordering protocol, and the validation based protocols. Okay, everybody, have you understood all the concurrency control protocols? Okay, so in this chapter we have seen the different concurrency control protocol. Okay, so all these protocols are used for the serializability, means all these protocols are used to execute the transactions in the serially. Okay, even though the concurrent execution of transaction is there, but the schedule whatever we have used, so that schedule must be serialized schedule. Okay, so to guarantee the concurrency control protocol, we have seen first the lock based protocol. Okay, then we have seen in case of deadlock, uh, in case of occurrence of the deadlock, how to handle the deadlock. Okay, then we have seen some timestamp based protocols. Okay, we have seen some validation based protocols. Okay, and also we have seen if multiple transaction want to log different parts of the database. Okay, then how to handle that, uh, uh, how to handle that granularity. Okay, using the multiple granularity concept. Okay, so have you understood all the points of this chapter? Is there any doubt in this chapter? Is there any doubt? Okay, so the last slide, only 4 MCQs are there. Okay, so we will togetherly solve these MCQs. The first one, the deadlock can be described precisely in terms of directed graph called. What is the answer? A, B, C, D. First A, wait for graph. Second, wait die. Third one, bound wait. And next one is the cyclic. Very easy answer. What is the answer? Deadlock can be described in terms of directed graph. So that graph is called as. What is the answer? Please give me answer. Please reply me. What is the answer for the first MCQ? Tasmin, give me reply. Tasmin. Please give me reply. What is the answer? How we can show the deadlock? Using which graph we can show the deadlock? Prashant? Prashant, are you there? Rutuja? Rutuja Benare? No one is ready to give answer. Okay, I will tell you. The deadlocks can be described in terms of directed graph, which is called as the wait for graph. Okay, so answer is answer A. Now the second one. A transaction may obtain locks but may not release any lock. It's called as which phase? Okay, in the, I think in the two-phase protocol we have seen this line or this point as the transaction may obtain the lock but may not release any lock. In which phase the transaction can obtain the lock but may not release any lock? What is the answer? Whether it is shrinking phase, growing phase, both phases, or none of the above. What is the answer? What is the answer? Are you there or not? Sonia, Sonia Kagde. Am I audible? Students, am I audible? Please give me reply. Am I audible or not? Hello? Okay. At least you are there. Some students, they are giving me reply. So please give me what is the answer. At least try to give answer. Let it be whether it is correct or wrong. So in which phase the transaction may obtain only lock but may not release any lock? What is the answer? Shrinking, growing. What is the answer? B. Yes, Geeteshwari Shinde. Growing phase. Correct. In the growing phase only the transaction can obtain the lock but may not release the lock. Okay. Now the third. Dash dash is not the concurrency control mechanism. Okay. The first one is lock based protocol, timestamp based protocol, log based protocol, and validation based protocol. What is the answer? Which is not the concurrency control mechanism? What is the answer? What is the answer for the third MCQ? Which is not the concurrency control mechanism? Timestamp, validation, lock, or log? Means which is not the concurrency control protocol? Which protocol is not comes under the concurrency control? What is the answer? Yes, many of the students have given the answer. Answer C. Log based protocols. Yes, answer is correct because all the other protocols are the concurrency control protocols, but only the log based protocol is not the concurrency control protocol. Okay, now the last. In the rigorous two-phase protocol, dash dash locks are released after the commit. Okay, in the rigorous. So this rigorous and the strict two-phase commit protocol. These two protocols are the extension for the two-phase protocol. Okay, so in that the rigorous two-phase locking protocol, which locks are released after the commit? Shared, exclusive, both locks, or none of the above? What is the answer? What is the answer for this? In rigorous two-phase locking protocol, after commit operation, which locks are released? Yes, last MCQ. Yes. Geeteshwari Shinde, Priya Kutsre both have given answer. Answer C. Okay, yes. In the rigorous two-phase commit protocol, two-phase locking protocol, the shared and exclusive both locks are released after the commit operation. Okay. Okay, so we have finished our 7th chapter. Okay, so I think from the 20 onwards or 19 onwards something, your ISC 1 will be there. Okay, and that ISC will be based on the second section. Okay, So we prepare for that. Okay. If in between means before your ISC, I will start. Uh, I will start the last chapter. Okay, 18 last chapter, that is 8th chapter. So I will try to finish that chapter before your ISC. Okay, so thank you for listening. So give me presentee. Call your roll numbers. Roll number 1. Next. Roll number 2.
Present, ma'am.
3.
Present, ma'am.
Next.
4 present, ma'am.
5.
5 present, ma'am.
6.
Present, ma'am.
7. Roll number 7.